Hi, good morning, everybody. Thank you so much for joining the Aquarium Online Academy. My name is Stacy, and I'm coming to you from the Aquarium of the Pacific in Long Beach, California today. I hope that you are ready to talk about adaptations because that's exactly what we have in store for this episode. Now, if you have anything that you would like to share, maybe you made some observations or you have some ideas that you want to share, or even if you have some questions you would like me to answer, this is how you get in touch with me. So the best thing to do is to text. Our text number is 562-286-1838. Again, that's 562-286-1838. And when you text in, if you would like us to say your name during this program, please make sure that you include that as well. Now, texting rates will apply. So if you need to ask for permission, make sure that you do. Now, if you are not watching this live, you can still send in your thoughts, ideas, and questions. You just have to do it via email. And our email is down there as well. It's live@lbaop.org. Now, the team that I have with me today are Jen and Carrie, and so they're going to help us out with the really cool images that you see behind us and also for all of those questions and ideas that you text in. So I hope that you are ready to explore. Now, we are going to be talking about adaptations. And here is the word right there. It's adaptation. Now, what is an adaptation? You might be asking. Or maybe you know. What is an adaptation? An adaptation is basically anything that a plant or animal has that helps it to survive. Now, these things might be something they have as part of their body. It also might be a behavior that they do, like running fast or flying. Those are all some different adaptations to help them to survive. Now, what does it even mean to survive? What are the things that you need to survive? Well, a lot of animals, and actually plants too, they need nutrients or some kind of food, right? For plants, they need sunlight, and they need like fertilizer. For us, for animals, we need food and we need water too. So sometimes the adaptations are actually there to help animals find food. We're really going to be focusing on animals today, so let's keep going with that. So maybe those adaptations help them find food. Maybe those adaptations help keep them safe because some animals like to eat other animals as food. And so to stay safe is another way to survive, right? And so those adaptations might be helping them stay safe. So we're going to be taking a look at a few different animals and those different adaptations, especially movement. All right, now I would love for us to start with a very unassuming animal. In fact, it might be an animal that you may wonder, does it even move at all? And that is a sea star. Now, sea stars are amazing animals. They are what we call an invertebrate. An invertebrate is an animal with no backbone. So we have backbones. That means we are not an invertebrate, okay? Our backbone is located right in the middle in our back. And if you kind of bend over a little bit, you can kind of feel some of the bumps. You might even be able to feel it up here, kind of where your neck and your back meet. All of those bumps are your backbone. And that's what gives us structure. So we can stand really tall. We can maybe even walk around sometimes. Our backbone helps us out with that. Now, sea stars don't have backbones, and they don't have a lot of things like us, which in some ways makes us think that they can't possibly be animals because they don't even have a face. Yeah, they don't have a face. It's crazy. But the thing is, they have other adaptations that are going to help them survive. All right, let's talk about movement. I want to give you just a moment to take a look at the sea stars here and think about how would they move? Do they move? And why do they need to move? Okay, so those are your questions. How do they move? Do they even move at all? And then why would you even need to move if you were a sea star? Okay, well, to answer one of those questions, do they even move at all? The answer is absolutely yes. Sea stars are movers. Now, they cannot outrun us. In fact, we can run much faster than sea stars. They can't even outswim us. If you can swim, we can swim faster than a sea star because sea stars actually don't swim at all, but they can move. Now, how do they move? Well, let's take a look. The first thing we need to do is look at the part of the sea star that is hugging a rock, and that is the bottom of them. So sea stars on the bottom of them have tons and tons of little feet. Do you see them? All of those little dots right there, all of those are their feet. And what's really cool is those little feet are almost like suction cups, and they're attached to a tube. So they're actually called a tube foot or tube feet, T-U-B-E. So tube feet, and they have lots and lots and lots of them. And we know that that makes it really good for sticking, right? So these sea stars here are really great at sticking. In fact, this one is sticking to the window of one of our exhibits, which is why we got this really cool picture here. So we know that they can stick, but how do they move? Well, those tube feet move. Now, on the backs of these sea stars, they actually have a little, it's almost like a hole. It's called a madreporite. Real big word. Don't worry about it. You don't need to memorize that. But they have like a little hole right on their back, and that little hole helps them to suck water into their bodies. And they need to suck water into their bodies because the water in their bodies is what kind of gives them that pillowy shape, but it also helps them with movement. In fact, the water goes into their little feet. So you can see here, you can see a little bit of movement here and there of these feet. But water goes into the foot and it makes it nice and straight. And then when water leaves the tube, it bends. And then it puts water in. And then it leaves the tube. And then it puts water in. And it leaves the tube. So they can actually walk around. Now, it's really hard to watch a sea star walk if it's not walking on a window like this. But we actually do have some videos of sea stars kind of moving around a little bit. Now, again, they are not the fastest animals out there. In fact, they're a little bit on the slow side. Now, some are faster than others. It really just depends how quickly they can get that walk, but they can actually move. Let's take a look. So you can definitely see that fish there can swim much faster than a sea star can walk, right? But you can tell that sea star's walking. It's walking towards the coral. Excellent. So they actually move pretty smoothly. They don't bounce up and down too much. Oh, it lifted its arm. I think it's trying to figure out what that is. And then it continues to move on. Okay, so now we know that sea stars can move, and they use all their tube feet for those movements. But why do they move? What is the whole point of this sea star walking over that way? What do you think is over there? Well, it's hard for us to know, right? I wonder if there's food. I definitely move when there's food over there. I go, woo, snacks, and then I tend to take off. Well, I have a feeling that sea stars kind of do the same thing. They may smell those snacks using their little tube feet. Yes, they smell using their feet. Would you like to do that? I don't know how I feel about that. But for sea stars, it totally works out, especially because they don't wear shoes. But they use their feet to smell out things. And if they smell a tasty snack, they may walk towards that tasty snack. Now, once they get to their food, their tube feet are actually used to kind of grab onto that food and bring it into the middle, because in the middle, that's where they eat from. That's actually where their mouth is. And what's crazy is their stomach comes out in order to eat that food. So those tube feet have a really important job. They help them to stick to things, they help them to walk around, and of course they help them to eat as well. So we know that sea stars maybe want to move because that's where the tasty treats are. But do they move for any other reasons? And the answer is they do. In fact, there are some sea stars that live in a place called a tide pool. A tide pool is a place where the ocean and the sand meet, and usually there's lots and lots of rocks. So it's kind of like land and ocean meet together, lots and lots of rocks, and sometimes there are big pools of water that are left over. Now, sea stars, a handful of them, are found in these areas, and if they're left out on a rock with no water, it's kind of tough, because sea stars are made to live in water. Remember, those feet work by water. They actually get their oxygen from water too. So they need to be in water. But they have this really cool adaptation where they can hang out without any water for a little bit of time. Now, again, it depends on the type of sea star. Some are better or more well adapted to live a life like that than others can. Some can't really hold their breath very well, so they're not going to be found out of the water. But these sea stars here are the kind of tide pool sea stars. Now, one of the things they may want to do is, as the water is kind of sloughing away, because tides move. Now, if you want to know more about these tides and tide pools, I encourage you to watch our episode on tide pools. It's pretty cool, all the different adaptations that those animals have. But sea stars may walk closer to where the pools are and not just get stuck on a rock. So that is another really good reason to move for water. All right, excellent. Now, let's see. We have Aiden Alexander. What makes some sea stars move faster than others? Ooh, that is a really good question. I have a feeling it has something to do with how fast the water can move inside their body. But another thing is there are some sea stars that are actually more flexible than other sea stars. And I know this seems weird because when we see them, they don't look very flexible at all, right? But they have kind of these slightly hard parts in their body, almost kind of like plates. And the ones that have plates that are a little bit bigger and a little bit tougher are not as good at being flexible. So those ones might be moving a little bit on the slower side. The other reason why they would move actually has to do with that flexibility. What if a sea star, just by chance, flipped upside down? All of its feet are then hanging in the air. This here is an upside down sea star, kind of. It's like half upside down, half not. So if it's completely upside down, it's not going to survive very well. So what it actually needs to do is a back bend. And when it does a back bend, it can actually pull itself back right side up. Now, again, the more flexible sea stars are going to be able to do that a little bit quicker than the ones that are not as flexible. So we can see here all of these little tube feet moving. Do you remember what helps them move their feet? If you said water, nice job. Yeah, so again, they put water in the foot and it stretches, and then the water goes out and it bends. So this is kind of crazy how all of these little tiny feet move and work together. So I have a question here from Junie from New York. Hi, Junie. Thanks for joining us. How do sea stars spit out their stomachs to get food? That's a really good question. I don't know exactly how they do it, but it's just something that they do. So just like, I would say kind of like how our tongue works, right? Like our tongue, we can stick it out or pull it back in. I think that's kind of what they do too. So their stomachs just kind of come out of the middle to do a little bit of eating before it comes back inside their body. Now, one of the good reasons why it does that is because a lot of sea stars like to eat animals that have shells. So it's like a clam or a mussel. They have a really hard shell like this, and they're incredibly strong. But they're not eating the shell. They're just eating the little animal squishy part on the inside. That's exactly what we eat too, actually. And so for us, we use tools to open it up, or we cook it and the shell opens up. But sea stars don't cook, and they also don't use tools. So instead, they're going to use all those little tube feet to attach to the outside of the shell and open it up just enough that their stomach can fit inside. Isn't that weird? So all of these different kind of movements are going to be really helpful for that sea star's survival. Okay, I think we might have another question about sea stars coming through. So while we wait for that question, Carrie's getting that going for us, I want you to start thinking about another invertebrate, an octopus. How do they move? Why do they move? All right, let's see. Jojo from Ontario. Do sea stars have eyes? Ah, they totally do. Now, we said they didn't have faces, right? Because they don't. So they don't have a face, but they do have little parts that are kind of similar to us. So in the middle, underneath, that's where their mouth is. And by mouth, I mean that's where they kind of eat from, right? Their stomach comes out and their stomach comes back inside. So that's their mouth. What about their eyes? They don't look like ours, right? They don't go, That'd be really odd. Instead, their eyes are actually on the end of their arms. So these little tube feet at the end here are actually light sensors. So instead of seeing pictures of movements the way that our eyes can see pictures and movements, their eyes see light and dark. So if you wanted to see like a sea star, it's actually quite simple. All you need to do is close your eyes. Now for us, we're like, well, then you can't see anything. But you can still see light. If you have your eyes closed and you take your hand and you put your hand over your eyes, it gets darker, right? And when you pull your hand away, it gets a little brighter. That's what a sea star sees. So they can tell if they're hiding under a rock or if they're out in the sunlight. So that's kind of what they're using to help them navigate around too. So yes, they have eyes. They're just very different eyes than ours. All right, fantastic. Now let's go check out our octopus friends. So how do they move and why do they move? We know octopuses move, right? Everybody has seen videos or cartoons that have octopuses moving around. So how do they do that? Well, here's a really good clue. Take a look at all of those. Now, it kind of reminds me a little bit of the sea stars, right? Does it remind you of the sea stars? These kind of round suction cup looking things. Well, for an octopus, it is a suction cup. Remember, for a sea star, it's a tube foot. For an octopus, it's a suction cup. But they kind of do the same thing. They stick. And when they stick, it's really good for walking, just like what those sea stars do. So yes, an octopus can actually walk around to explore using those suction cups. Now, that's pretty incredible, right? So they can stick, and all of those suction cups, they have so many of them, it's estimated for a giant Pacific octopus like this one, each arm can have up to 250 suction cups. Just imagine 250 times 8. I can't do the math really quick right now, but maybe you can. So 250 times 8 suction cups, and you have to make them all work together. Oh my gosh. My friend Jen here just said it's 2,000. That's some pretty good math. All right, so 2,000 suction cups. You make them work together in order to walk somewhere. So let's watch how they walk. Okay, again, the arms are really flexible, so they can kind of move the arm with their muscles, and the suction cups stick, and then they can pull forward. So they just kind of, okay, pretty cool. Now, let's see. A question from Isaac is it true that octopuses can shapeshift? Well, shapeshifting is, it's a little tough to say exactly because it depends on what you mean by shapeshifting. They are incredibly squishy. So we said that they are invertebrates, right? That means they have no backbone. So what that means is their entire body is squishy. The only hard parts of their body are really their mouth, which is called a beak, and it's located in the center of all of the arms, and also the lens of their eye. So they have one little part of their eye that's a little bit hard, but their mouth is always the biggest part of their body that has that's tough, right? So what that means is they can actually squeeze into or through any space that their mouth can fit in. So just imagine if there was this big octopus here, and the mouth was about this big. If we gave it a hole this big, that big octopus can squish through it. It's really incredible how well they can kind of, in a way, shapeshift. Now, there is an octopus out there called a mimic octopus that does actually mimic how other animals move. And that's one way that it stays safe. That's actually another adaptation that it has. So there are some octopuses out there that can shapeshift. Another thing about octopuses that is kind of similar to shapeshifting is how well they can change their color and the texture of their skin. So that doesn't really have much to do with movement, but it is a really great adaptation to stay safe. So take a look at that. Did you see what happened? Okay, maybe my friend Jen here can rewind it so we can see the very beginning again. So the very beginning, it's very red, right? Like dark brown red. And it's smooth, maybe just a little bit bumpy. But then take a look at this. Wild, right? So in a way, it kind of did change its shape. It changed the texture of the skin. It became very bumpy, right? All of the skin bits kind of pulled up a little bit to make it almost spiky. And then it turned a totally different color. Even not just one color, but a couple of colors. So that's a really neat adaptation that these octopuses have to stay safe. It also helps them to maybe get a little closer to their food so that it's much easier for them to catch food. It's multi-purpose. And that's actually why they move too. They move because they want to find food. They also move so they don't become food, right? So that's a really good reason why an octopus moves. Now, octopuses are also pretty cool because they're quite smart, especially for an invertebrate. They're so smart, in fact, they can actually solve puzzles that we give them here at the aquarium. So that intelligence, that smartness, it's what's going to drive them to go explore. Now, octopuses, for the most part, are kind of shy. They like to hide a lot. But sometimes they'll actually go and they'll explore their habitat. They walk around trying to kind of see what's going on out there. So it's a really neat thing that they can do. Now, they are going to use their eyes to see when they explore, but they're also going to use their suction cups because very similar to those sea stars, those suction cups can actually smell. So as they walk around on things, they're actually smelling their surroundings. Pretty wild. Now, Lydia from Ontario is asking, how and when do sea stars sleep? That's a good question, Lydia. I actually don't think sea stars sleep a lot. I think sea stars just kind of are. They just kind of are there. They don't have a brain. And I know that sounds crazy because, we think of animals as having brains, right? But sea stars don't have brains. And so they don't need to sleep to allow their brain time to rest. So they just kind of hang out there. If they do rest, there are definitely periods of time where sea stars don't really move too much. And then sometimes they move a little bit more, kind of depending on the day or the time of day. So I would say they rest, but not really sleep. And where do they rest? Wherever they're stuck. So remember, they stick to things, and that's how they're going to want to rest so they don't get washed away by a wave. So most of the time, it's probably going to be on a rock or something kind of harder. All right, good question. So let's take a look at an octopus again. Now, we did say they walk around, but did you know that an octopus can also swim? They can. Octopuses can swim because they have this thing that's very similar. I think it's actually called a jet propulsion system. Basically, what they can do is they pull water into their bodies. Now, an octopus is kind of weird. They basically look like a giant head with arms, right? But in fact, their head here is where their eyes are. The arms are all here. But all that back part that looks like where their brain would be, that's actually their body. That's where their internal organs are. And so that is an open system, which means water can actually go inside that system. Now let's take a look here. That's the part I'm talking about. Now, do you see that little tube, that little hole that's opening and closing? That is their jet propulsion. So the really big hole, this one right here, pulls the water into its mantle or its body. And then this little one right here, it's kind of like a tube. It spits it out of there. So when the water goes in here and comes out of there, it moves kind of like a balloon. If you've ever blown up a balloon before and then you let it go, and all the air comes out of that small little opening of the balloon, and the balloon goes, and it flies. That's basically how an octopus can swim. So it's a really fun thing to actually watch them suck in water there, and then spit out water through that tube. Let's watch it again. All right, do you see how those two things kind of work together? And that's what's going to help it swim. Now, they can even go a little bit faster than that if they really, really wanted to get out of there. This octopus here was hiding, and it was hoping that it wasn't seen. But when it noticed the diver was still hanging out, it wanted to get away. So it was able to use its jet propulsion to kind of swim away. All right. So octopuses are pretty amazing. They can not only walk, but they can actually swim too. Now, I do want to talk about one last animal, and we're going to do this a little bit quickly. I'm hoping that we can talk about maybe sharks. Okay. Sorry. I wanted to make sure that my friend Jen there knew that we were talking about sharks so she could bring up the cool pictures. So sharks, do they move? Absolutely. How do they move? I'm sure you know they swim, right? But how do they swim? Have you ever really thought about that? They use their fins for swimming, but what are those fins actually doing? Did you notice they have a lot of fins? Take a look at them. There's fins on the top, there's fins on the bottoms, there's fins on the side, and of course, the part you can't see, the tail. All of those fins work together to help the shark swim around. Now, we have a really cool camera that we have in our exhibits. A handful of our more popular exhibits have these cameras inside. You can even watch them on your own if you would like to. All you have to do is go to our website, aquariumofpacific.org. This here is Shark Lagoon. Now, you can see there's lots of little fish in here, and there's lots of bigger fish too. So yes, sharks are fish. Now, let's see how they swim. I'm going to give you a moment to observe, and I want you to think about what are all those different fins doing for that shark. Now, while you're observing, Johnny is asking, what are octopus's predators? That's a great question, Johnny. A lot of things can eat an octopus, and the reason why is because they're squishy. So a lot of things that eat octopuses are going to be bigger than octopuses. Sharks can eat an octopus. Fish can eat octopuses. There are also birds who do. Even octopuses can eat other octopuses. So there are a lot of things out there that do. Oh, seals. Seals are another animal that can as well. So lots of different things out there, lots of predators. So having all those adaptations to hide and to get out of there is a really good thing for an octopus. All right, so as you've been observing these sharks swimming, what have you noticed? How do these sharks use their fins? Well, to push them through the water, what are they using? They're using that tail, right? It's called a caudal fin. That tail is swimming or pushing side to side, pushing that animal through the water. So then why all those other fins? What's the whole point? Well, if you look carefully, this shark is, ooh, hi, big shark. The shark is kind of torpedo shaped, or it almost looks like a football that's kind of been pulled out a little bit. And if you've ever seen a football being thrown through the air, you may have seen it spiral. And that's exactly what would happen if this shark had, had that tail pushing it through, but none of the other fins. So those other fins stabilize it so that way it can swim like this instead of spiraling. Okay, how does it steer? Have you noticed it? I just keep blocking that shark. Sorry, buddy. How is this shark steering? Because it's definitely turning. Well, it can use its tail a little differently. It doesn't need to swim side to side perfectly like this, right? Maybe this side's a little longer and this one's short. A little bit more and short, a little bit more and short. And that's going to actually help it turn. The other thing, take a look at those side fins. Those are called pectoral fins. Those side fins help it have direction as well. So the side fins can help them to turn if they kind of lean a little bit. It can also help them kind of go up or down. So those side fins in some ways are very similar to an airplane's wings. It gives them a little bit of lift. So it's kind of cool to watch these sharks move and really take a look at those fins. So these are all things that we can do when we want to explore different things. You don't even just have to do this with animals. You can do this with plants too. Take a really close look and see if you can figure out how is that animal or plant surviving? What are some of the adaptations they have that help them survive? How do they get food? Do they move? How do they move? And why do they move? And then maybe some of that movement is, ooh, that's a real good view. Thank you there, little zebra shark. You can see how it's turning with those side fins. Perfect. So it's pretty amazing to just sit there for a moment and watch nature at work and try to figure out what that's all about. Now, I do encourage you to continue to do that sort of thing. Again, you can take a look at any of our webcams whenever you want to. A lot of them have to do with light. So just remember on the Pacific coast here in Long Beach, when our sun will be up and when it will be set, because like Shark Lagoon here has natural lighting. So when it's dark, it's pretty tough to see. Now, if you're curious about something like a turtle, did you notice the turtle there? If you want to learn more about turtles and maybe even how they move around, I encourage you to stick around. We actually have another program coming up just after this where we're going to explore the world of turtles. So I hope you're ready to do that too, because it's so much fun. Thank you all so much for joining us this morning, and hopefully we'll see you a little bit later too. All right, thanks again. Bye.